Hello, Year 11, and welcome to this, the first video for our fourth topic. We're looking at collecting and, I guess, representing data. Mostly what this topic is about is graphs, actually, and of course you've seen many of these before. There might be a couple of new ones, and a new way of approaching them, and certainly a bit more rigour about sort of justifying why we are doing things a certain way. Anyway, now first video here, you'll see there's an awful lot of terminology here. The example questions, look, often these questions don't fit very neatly in a little space like that, so they're blank for the time being. I'll see if I can fit them in. And I, shout out to Randall Munro and his XKCD webcomic that certainly has lots and lots of amusing graphs on there. That's what I like. Jokes about graphs. There we go. Bacon. Yeah, hilarious. Anyway, we're going to look at interpreting graphs in this first video here. Why would you use a graph? Well, it's good to see at a glance. Some people don't like the numbers. It can help to identify a trend or a pattern sometimes. We need to choose the right sort of graph appropriately. And there are a few different types of graphs here I talk about here. Now, something I've picked up or I've noticed is that the sort of the syllabus, the curriculum that we use here, tells us, or we are using different terminology to that which I'm most familiar. Right, we've gone back to using words like bar charts and pie charts that I have previously railed against and said, no, that's a silly, inexact term, but, well, you know what, it's back in. So bar charts and column graphs, same sort of thing. You'll be familiar with what they look like. Typically, we have a horizontal and a vertical axis, and we have columns that rise vertically. Right? They're good for reading off values. Right? You can read values, like how tall those columns are. That's relatively easy to do. And so it's good for looking at which column is the tallest, for example. Right? It's good for that. You can go, which column is the tallest? And how tall is that column? Right? Column graphs are good for that. I'm going to tend to use column graph, but if it says bar chart, that's probably what it means. Now, line graphs. Good for showing a trend. Particularly in continuous data, and we'll talk about types of data later on. Line graphs are good when we might want to interpolate to estimate a value in between things. So line graphs are good for that. Things that change steadily, constantly, like the temperature in a classroom or something like that. It doesn't jump straight from 25 to 26 degrees. Right? It will move gradually from one to the next. So line graphs are good for that. Harder to read values off, but good for seeing a trend. Sector graphs, or pie charts if you must, they're good for comparing the relative size of different sort of scores or quantities, particularly as a proportion of the total. It's hard to put things in order in a sector graph. It doesn't really work that way, but it's good for, at a glance, going, oh, well, that particular category, that's the biggest one, or these ones together, they make up more than 50%, or something like that. So good for looking at proportion of the total. And divided bar graphs are very much the same. They're essentially a sector graph, but a rectangle. They can be slightly easy to construct because you don't need a protractor. And slightly easier to read off, probably, if you don't have a protractor. Area charts, not mentioned in the textbook, but they do pop up in the exercises, and students from experience often make a bit of a mess of these. Area charts, we stack figures above each other, and basically they're sort of like a divided bar graph that changes over time or something. So we can see how the proportion of the components changes over time. Rightio. Here is an example. These tend to get a bit long. We have a column graph here, right? A column graph or a bar chart, if you like. We've got some things there. What is the size of 1 unit on the vertical axis? Right? Here's our vertical axis, and it's broken up into units of 50 downloads. 50 downloads. It's got units, so we'll put them in. Oops. Right, there we go. How many songs were downloaded in April? Right, so this would be hard with a line graph or a sector graph or something, but up here to April, right? I follow it up now. I can see that it sits, well, it depends on the thickness of that line, but I'm going to say at about this little grid line here. I'm going to follow that across. Let's do from the top here. Rightio. Now, I've got to be a bit careful here. I can see that I've got 5 little squares that go from 250 to 300. That means that they represent, right, 10 downloads each. So, I am 30 downloads above 250. I'm 280 downloads, or thereabouts. In which month were 100 songs downloaded? Right, here's my 100. Follow that across. Looks a lot like July to me. And in which month were the highest number of songs downloaded? Why might that be so? Well, I can see, right, this is where a column graph is good. At a glance, that January has the most. January, why might that be the case? Lots of people on holidays. On holidays, lots of spare time. Perhaps. I don't know. Might warrant further investigation. That'll do us, I think, for that example there. Rightio. So that is a column graph. Let's have a look at how we apply this to a sector graph or a pie chart, if you like. Here we go. Always read these things fairly carefully. Shows the overseas countries where Australian students studied during 1 year. Rightio. What was the second most popular overseas country for Australian students? Now, if I didn't have these figures written on here, I would have a very hard time trying to work out which one of those was bigger. Compare that to a column graph where I've got 2 columns side by side. It's very straightforward to work out which one's taller when now I've got 2 columns side by side. But when I have 2 sectors like this, it's difficult. But fortunately, this is labelled with a percentage. Right, so the second most, New Zealand. They won't mind if I use the abbreviation. What percentage of students chose neither the United Kingdom nor the United States? So not this one or this one. We need to add the others together. So 17 and 6 is 23, is 27, is 55%. Alternatively, I suppose I could add these two together and I get 45% and take that away from 100. Right, that could be easier as well. If a total of 3,695 students were surveyed, how many of them went to Canada? Well, 6% of this number. So 0.06 times 3,685. Okay, that's going to be 221 students went to Canada. Now, calculate the nearest degree, the size of the angle for the others. So other is 17%. So what I want is 17% of 360 degrees. So 0.17 times 360 degrees equals, let's see if I can get my calculator back there, here it is. Right, 0.17, that's 17 divided by 100 if you like, times 360 equals 61.2 degrees. To the nearest degree, 61 degrees. Right, yeah. And does it look about right? Does that look like about a sixth? It does to me. Now, that is it for interpreting graphs there. Oh, look, we've got another funny comic strip. Hilarious. Isn't that wonderful? Oh, now what are we going to do here? Oh, that's fine. Right, we didn't have to draw anything. I've got a fair bit of spare space. You can see some, you know, nice sector graphs and column graphs there too. Self-referential. Now, that's it for the first video. Any questions? Save them up for class. Otherwise, I'll see you there. Cheers.